So the second part of 3.2, we're going to look at linear combination, and also called elimination. And the reason you call it elimination is because you're going to try and make the variables cancel out. Again, a very strong suggestion, variables must line up. It doesn't mean you look at the problem, variables don't line up nicely, you can't use this method. You are allowed to move things around, shift them around to find or put them in a position where they are lined up nicely. Just make sure you're doing it all correctly when you're moving those pieces around. Now what we're going to see here is you're going to get some options. You have some freedom if you want to add the equations, subtract the equations, but you can combine like terms just like if the variables were in the same equation or the terms were in the same equation. So if you're looking at the problem, 7x plus 3y equals 29, 4x minus 3y equals negative 7. We can combine these two equations together, and we can do that by adding or subtracting them. What you need to think, you need to do some mental math, problem solving, and think, elimination. I want to eliminate one of the variables. We have 3y and negative 3y. If you add those together, they add to 0. That's the elimination part right there. Getting them to 0 eliminates the y. When you have two variables, you can't solve for that value. If you eliminate one of the variables, now we'll just have the x variable, then you can get that x by itself. So if I'm doing this work, I'm going to add the equation. Again, you have options. You could add, you could subtract, but you want to do the method or the operation that's going to make a variable cancel out. The y's cancel out there, they go to 0. 7x, 4x goes to 11x. 29 plus a negative 7. Just watch your signs. That's one of the common mistakes is just adding and subtracting incorrectly. Okay? Now we have 11. Divide both sides, x equals 2. And just like before, now we have to get our y variable. So we have x equals 2. It doesn't matter which equation you want to go back to. Look and see which one looks nicer to you. Whichever one looks a little easier, that's the one you should go to. I'm going to go with the top equation. 7 times 2 plus 3y equals 29. And that's an equation. There's only y. Get that y by itself. Okay, subtract the 14. And y equals 5. And again, I would like your final answers as an ordered pair. Okay? Put it as an ordered pair, so 2, 5 would be our final answer for that problem. Now, this was nice. Right away, everything lined up. We were able to add, and the y's canceled out. Unfortunately, it's not always going to be that easy. Okay. 3x plus 9y equals 33. 2x minus 4y equals negative 8. Adding them, the x's won't cancel out. Subtracting, the x's won't cancel out. Same thing for the y's. Adding or subtracting, that's not going to cancel out. You need to think of a way to make them cancel out. And in math, it's nice. As long as you do an operation to every term in the equation, you're allowed to do it. It may change the way the equation looks, but it's still the same equation underneath. So we can multiply and try and make the x's a similar coefficient so they will cancel out. So if you multiply the top by 2, the bottom by 3, this is going to make the x's now have the same coefficient. Okay? So if I multiply through basically the distributive property, 6x plus 18y equals 66. Over here, same thing. Multiply the 3 through, 6x minus 12y equals negative 24. Now what you have to look at, or what you see here, is now the x's both have 6 as the coefficient. Okay? So I can subtract those. 6 minus 6 is 0. And that's the way you have to think about it. How can you make the x's be eliminated? Well, if you add them, you get 12x. In this case, we're on subtract. 6's cancel out. 18 minus negative 12. Again, this is a common mistake. Just working a little too fast. People just do 18 minus 12. It's 18 minus a negative 12, giving us 30y equals 66 minus a negative 24 gives us 90. do the work to get y by itself, and you get y equals 3. Again, you have to go back, pick one of the equations, the original equations. You could use one of these two equations, but usually they're gonna have some bigger numbers and just a little more work to work through. So pick one of the original equations. The numbers are usually a little smaller. So I'm gonna go with the top one again. Now, the reason I'm picking it is to get rid of the negatives. Okay, I don't want to deal with those negatives, so I'm using the equation that has all positives. Okay, so I have 3x plus 9 times 3 equals 33. Make sure you put it in the right variable. Okay, just multiply through, get the work done. And 2, 3 is our final answer. Okay, so just make sure you take your time and watch the steps. Okay, watch the steps and make sure you have the correct operations. Okay. I'm going to do one more example, and this example again, nothing multiplies through or nothing cancels out if you add or subtract right away. You need to think about how you can make either the x's or the y's. You don't have to multiply both equations. Okay, so you need the problem solving to find what's the best way to make something cancel out. The surefire way, what I did last time, if you multiply or just switch the coefficients in front, that's going to give you the same coefficient for the x variable or whatever the first variable is that you're dealing with here. So if I multiply through here, okay, just check my math there, 12, 18, 45, yes, 12, negative 40, and 16. Okay, again, that first term, 12x, 12x, if I subtract those, it's going to make the x's be eliminated. So if I subtract those 12s, cancels out. 18 minus negative 40 gives me 58y. 45 minus 16 gives me 29, sorry. Okay, and now when I divide that through, we have y equals a half. Okay, so in this case, it's not a nice integer. Fractions are okay, just you're gonna have to deal with them. Right now, 1/2 or 0.5 I'd be fine with. Okay, I'm gonna go back, plug into my top equation again. Okay, just take your time, go through that math. 6 times 1/2 is 3, subtract, so you get 4 equals 12. And I have 3 1/2 as my final answer. Okay? So it's another example of the basic system using linear combination. Here we have 6x plus 10y equals 7, 3x plus 5y equals 2. Now this one, I see I have 6 and 3. I'm not going to multiply that top equation. I'm going to leave that. I am going to multiply my bottom equation by 2. And this is showing that you don't have to multiply by both equations. 6x plus 10y equals 7. That stays exactly the same. 6x plus 10y equals 4. 6x and 6x. So when I subtract this, the x's cancel out. 10 minus 10, the y's also cancel out in this case. So I'm left with just 0 on the left-hand side. 7 minus 4 is 3. So here we have that 0 equals 3. All the variables cancel out. It's not a true statement, so we're going to have no real solutions. So again, if all the variables cancel out, you have to think, do I have a true statement or a false statement? False statement, 0 does not equal 3, no real solutions. Here we have 3x plus 6y equals 2, 9x plus 18y equals 6. The similar thing is going to happen here. I'm going to multiply that top one by 3. I'm going to make these be the same 9 coefficients here. So I get 9x plus 18y equals 6. 9x plus 18y equals 6. Right away I should see, okay, I have the same equation on the top and bottom once I multiply through. And when I subtract these then, x's cancel out, y's cancel out, the 6's cancel out. 0 equals 0. So in this case, we have a true statement. All the variables cancel out, but we do have 0 equals 0, which is true. And that means we have infinite many solutions. Just abbreviating the infinite solutions there. Okay? So that's elimination or linear combination. Okay? You want the variables to line up. So you might need to maneuver some things around. And once you do that, you need to do some problem solving to see how can you make a variable be eliminated. Okay? So that's going to be the mental math and the basic skills of just adding, subtracting, knowing what cancels out to give you 0, so one of the variables gets eliminated.